OR gate, right? It's an OR gate. So now what does this rule say? Pretend this is an OR gate, right? So now it says if there's an input here, A, right, with 0, the output will be A. But now, so what do they mean if they say that? Let me show you something. Remember the truth table of an OR gate, right? The basic operation of an OR gate. If this is a 1, right, and then this is a 0, 1 or 0 is 1, right? So listen to what I'm trying to say now. So it means A is a variable, guys. It's a variable. So now it doesn't matter what A is. If you OR anything with a 0, right, the output will be, and it will be that thing. It will be that thing. It will be this thing. So it's called the identity rule because this and this will be the same. They will be identical because you are ORing it with 0. Anything. So remember, last time I touched on a variable, I said, for like example, if you are programming, you're going to declare name as a variable, right? Name can hold anything. So this name, it can hold, let's say, it can hold Larry, it can hold Michael. Right? So A is just a variable. So now, what does it mean, sir? It means that if we have this, right? Let's say A, B, C, right? Then we OR it with 0. The answer will be ABC, right? It's just the basic operation of an OR gate. If we go back to the OR gate, 0, 0, the truth table of an OR gate, 0, 1, 1, 0, 1, 1. What did we say about the OR gate? We said OR gate 0 and 0 will be 0, 0 and 1, or 1 will be 1, 1 or 0 will be 1, 1 and 1 will be 1. So do you see what the identity rule says? The identity rule, it says anything odd with a 0 is that thing. Here it is. Here is your identity rule, right? Anything odd with a 0 is that thing. So A or 0 is A. So you need to please write it down somewhere because it's not in this. I'm lazy every single year to update this and write the rule name. In the past, when you solve, you'll see when we solve problems, right? They will say simplify using Boolean algebra techniques. Then when you simplify, let's say you get to the step, you need to write the rule name. Others are getting it right with the rule numbers. They just say rule 1, rule 2, rule 3. But I think the best way is to always know the rules. The rules, right? So A or 0 is an A. So please write it somewhere. Identity rule. It's there on YouTube as well. I'll paste those links. A or 0 is A. So now of the AND gate. Still identity rule. This time we are saying with an AND gate. So what do we know about an AND gate? An AND gate, we know that if we have 1 and a 1, right? The output will be 1. Right? We know that. Then we know that if we have a 1 and a 0, right? The output will be 0. Now, did you see the relationship between these two in green? So now what happened? What happened is that anything ended with a 1 is that thing. The output is that thing, right? So In this case, we said 0 and 1. Here's the 1, right? We ended 0 with 1. The output was 0. If we end a 1 with a 1, the output will still be this one here. It will still be a 1. Okay, so what does it mean? So this means that, remember, this A is basically just a variable. It represents name. So you don't know what name is there. It can be Michael, it can be Larry, it can be Lesego, right? So let's say you had A, B, C, right? As an input. Then you end it with a 1. Remember, this is a variable with a 1. The output is going to be ABC. So let's look at the truth table of a NAND gate, right? Of an AND gate, I mean. A, B, 0, 1, 1, 0, 1, 1. Great stuff. So now what does the AND gate say? The AND gate says 0 and 0 gives us a 0. 0 and 1 gives us a 0. 1 and 0 gives us a 0, right? 1 and 1 gives us a 1. So what are we saying? How can we relate it? How can we relate it to here? Let's change our color. Let's go for green. So we are saying anything ended with a 1, right? Check this out. Here's a 1, right? We end A with a 1. Let's say this is 1. This is A. So the output is A, which is 1. The output is this thing, right? A is this one, B is a 1. So the output is A. Here's A, right? Again, let's end anything with a 1. Here's a 1 here, right? Then we ending, this is A in this case, right? We ending anything here. Anything ended with a 1, it's that thing. So it is 0. This is something that is ended with a 1, which is 0, right? Now we are here. We end with a 1. So here's a 1. So it means our A is 0. Here it is 0, right? Again, this one won't apply because we're not ending with a 1. So now, you see, for these three combinations, we know that anything ended with a 1 becomes an A from the AND gate operation, right? So this is the identity rule. So it means with an OR gate, a variable odd with a 0 becomes that variable, right? With an AND gate, a variable ended with a 1 becomes that variable. So it means anything, let's go back again here. In your circuit, anything or with a 0, it's going to be that thing. It's going to be that input 1, input 2. The output will be that input 1, right? And then here, anything ended with a 1, the output that first input. So this is our identity rule. Okay, so let me just go back. These are the 3 most important ones. Then idempotent law says that if you have 2 variables that are the same, A or A, the output will be A. Now, what do they mean, sir? Let's go back to our OR gate, right? They say if you have 1 and 1, 1 or 1, 1 plus 1, 1 or 1, the output is that thing. It's that thing because they are the same, right? A or A, the output is A. Here, A is 0, B is 0. The output is 0. 0 as well, right? Yeah, the output is 0. A or A is this. So this is us using the OR gate, the first rule of the idempotent rule. So now you can just say that if both variables are the same, the output is one of the variables. You will see when we simplify, you're gonna get something like 1 plus A. Where is it? Okay, here it is. Okay. Then you will see where this comes from when you get 1 plus A. This thing somehow becomes a 1. You'll see when we simplify. Let's go step by step, right? Here it's A and A, right? So it's the AND gate. If they are identical, 0, 0, the output is 0, meaning the output is A. 1, 1, the output is 1. 1, 1, the output is 1. So that's what the idempotent law says. Identical with an AND gate. If the same variable ANDed together, the output will be one of the variables, right? Here, the same variable ORed together, the output will be one of the variables. Okay, now annulment law. Annulment law says that if we have an A, then we OR it with a 1. The output will only be 1. And then it further says, if we have an A, then we end it with a 0. The output will be 0. But now let's see if they're telling us the truth, right? A or 1. Let's check. From the truth table of the OR gate, what do we have? They are saying A or 1 is a 1. So 0, we're going to look for something that's odd with a 1, right? Odd with a 1. 0 odd with a 1, it's 1, right? So it is this thing. 0 odd with a 1, it is this thing, right? Agree? 0 or it's this thing. And then again, they are saying A ended with a 0 is 0, right? We are here. A, we don't know the value of A, so we need to check for when we had 0 in our truth table. Here and here, right? So now A and this, it became 0, you see? Here's the 0. So it means annulment, I think I describe it by saying it means empty. So it means this thing gets absorbed. It doesn't exist anymore, right? So here's A. A can be 1, it can be X, it can be A, B, C, D, E, right? You end it with a 0, you get that 0 as an output. Again, A or 1. I explained it here. A, we look for 1. Here is our 1. Here is our 1. And here is our 1, right? So in this case, A is 0 or 1. The output is this thing. We throw the A away. 1 or 0. The output is this thing, is the 1, right? Remember, 1. So meaning our A will be here, and then this will be the 1, right? Then and this 1 as well. With, okay, let's say A with a 1 here, the output will be that 1. So in simple words, just do this one. In simple words, check. This is your A. And then this is your 1. We are saying that no matter what values do you put here, the output will be a 1. So we are bold enough to make that statement, right? But now, sir, how sure are you? All right, let's see. Let's set A to be 0. 0. 1, right? 0 or 1, the output is 1. Do you see that? So meaning our statement for now, it's correct. So let's change it to 1 and see. If we say 1 and a 1, 1 or 1, the output is a 1. So do you see it doesn't matter what the value of this A is. So that's how you would prove it. That's how you would explain it. Just means that the circuit will still work. We take this second input, we ignore the first variable, right? The first variable. Okay, but today I want to ask you something so simple. Let's go to how they will ask it. So this is in your exam preparation 2. This one, I'm just gonna go through the laws as well. So before you write an exam, make sure that you know all those laws first. I used to memorize them. Just make sure that you memorize them. This is my exam notes one. Just make sure that you memorize all of them. And then normally I used to encourage people by write them down before the exam, right? Not copy, write them down on your page, right? Then maybe write down the law names as well. So memorize this. And then with that, you can always find your answer here. So here we're just saying A or 0 is an A or 1 is a 1, A and 0, A and 1 is an A or A is an A or not A is a 1, A and A is A and not A, 0, then A not is an A, right? So that this is double negation. Here's that absorption, A plus AB is an A. Then anything that has brackets is distributive, right? It's a distributive law. You're going to multiply out the brackets, but I have that as our example here. Let's see if I still have it in memory. Okay, great stuff. So what do we have here? We have F is equals to BBC, right? B, B, C, or B, C not, C not, right? Then we have not A, B, C, not A, B, C. Not C. All right. Let's check. You see, we have BB, BB. I think we can do something here. Let's see. A and A. Which one gives us A and A? You see, A and A is an A. So B and B is it's a B. Now, what's the name of that law? It is the idempotent law, right? A and A. So why are we saying that? We are saying B, B, B. Yeah, B, B. B and B, it's 1B. It's idempotent law. That's what we're saying so far. But let's just look. So we're going to have a B, and then we're going to have a C. Right? Just look. C and not C. This two, we know it's just one, not C. Idempotent law, right? It's this law. B and A, it's an A. So not C and not C, it's not C, right? And then here, they were trying to kill you here. Eh? So this is we're going to factorize here. We're going to take not A, B, C, not A, B is gonna be our common factor. This, right? And then we're gonna have C and not C. So let's see what we have. C plus not C. Let's just see. We have the C C plus not C, it's a 1. You see, here's the law, right? C plus, so C plus A plus not A, it's a 1. So C plus not C, it's a 1. So now we more or less know which rules we're going to use. So let's start. So this is how we start, guys. B and B, it's a B, right? So we're going to have B, C, or, so we combine these two. We said the name of the law was idempotent law, idempotent. Now we are here, B, not C, not C, not A, not A. Sorry, A and A is an A. So not C, this is the same as A, right? A and A, because they're identical. It's one of those things. So we're going to have B here, and then we're going to have not C. The next one. So here we can see a relationship already. This A naught is the same as this one. B is the same as this one, right? Then we left with C plus C naught. So this is A naught. So if we take out A naught B, to make this this term here, we will need a C, right? A naught B, C, it will give us this. Then we need to add A naught B, C naught to get. So now, so when you do this on the side here, you need to write the laws of your rule names. So we know it's content, and then let's get idempotent. Let's get this spelling. Idempotent, right? It's fine. Okay, and then the next one is, I said anything that has brackets is called the distributive law, right? Distributive. Distributive is basically when you multiply out, when you multiply in, that's distributive, right? So now, what do we do from here? Let's continue. So here, B is our common factor here. We're going to take it out, right? B. Then we will be left with C plus not C, right? Look at what we did. We took out B as a common factor. Here's B. B multiplied by C, it's BC. B multiplied by not C, it's B not C, right? Now, C plus not C, which rule is that? C plus not C. Let's see. A plus not A. So C plus not C, it's a 1. It's this rule. I'll get you in the name of this one. It is that rule, okay? So what do we have? So we have A not B, C plus not C, it's a 1. Oh, sorry, guys. Okay. Now we also know here that this is going to be a 1 as well, right? Sorry. C plus not C, it's a 1. Coming from here, C plus not C, it's a 1. Now we will only have not A, then we will have B, right? So we actually just have B plus not A, so it's going to my favorite partner, right? Remember I said 1 plus something. So that 1 plus something, guys, they like it. They like it. When you factorize, I can see it already. And that 1 plus something is always a 0. Let me show you. Sorry, it's always a 1. I mean, A plus 1 is going to go here, annulment law, right? So here, what do we do? Why am I saying that? I'm saying we take the B as a common factor, right? B multiplied by what will give us this? B multiplied by 1 is going to give us this B, right? And then here, the only thing that's missing is a not A. So what is 1 plus A? 1 plus A is basically a 1. Let's go back to those ones that are here. A plus not A is equals to a 1. And then 1 plus A is equals to a 1. Oh, wacht net 'n bietjie. That's not A. Okay. No, we can't do that. We can't do that. So we leave it at this. Do you understand? Do you understand? We can only say 1 plus A, right? We can only say 1 plus A is equals to 1. This is not A. You see? So now our rules here, they only give us, let's see, 1 plus something. If it was A plus not A, it was going to be 1. So I thought we were here, A plus 1. So it's a 1. So now here they were trying, you can see that this was one of the exam questions. So we can't do anything here. Don't make that mistake, right? Why was I a bit confused? Because I just saw 1 plus A and I know it's a 1, but only 1 plus A. This is not variable A. This is not A. So it can be 1, right? Are you guys with me? It can be 1. So if I say 1, okay, but we're not gonna know. But yeah, let's leave the example. So we don't have this. The final answer will be B, 1 plus A naught. Are you guys with me? Any questions with this one? So what did we see? We basically just used all the rules that are here. That's it. That's the only thing that we used. When we saw an A and a 0, even if this can be A, B, and a 0, we're gonna put a 0. Right? The one that we used the most was A and A is an A. A and A is an A. And the dependent law, we used it so many times. We used it here. B, not C, not C. Then we use this one as well. C plus not C. What is C plus not C again? We said it's a 1. We use this one. I'll just try to prove it and see. C, oh, this is and here it is. C plus not C, we said it's a 1, right? Let's prove that quickly. C, so here we have A plus not A, we say it's a 1. So let's prove it quickly so that we can know what rule is that. So if you don't know, you can always draw it. Remember, you need, this is an OR gate, right? The truth table of an OR gate. So now you need to know that if you have 0, this is C plus not C. So we just testing A or not A, right? So not A will be a 1. we say the output is a is a 1, right? So now vice versa. So imagine this is C and then this is C naught. So let's say C is 1. C is 1. Not C will be the inverse of C will be a 0, right? 1 and 0. So this will be a 1 as well. So this is what that law is just saying, right? C plus not C, C plus not C. Are you guys with me here? Before we jump to the next, okay, before we jump to the next question. All right, this one, it was, I don't know how many marks was this, but maybe more than 12, definitely more than 12. Let's look at the next one. The next one is a bit easier. Exam preparation 2. Oh no, this doesn't look easy. You see, A plus, not AB. You must ask yourself, I've seen that before. If you go to exam, notes 1. Is this exam notes 1? Okay. Let's do this paste here first. Okay. Here we know that this is distributive, right? We're going to multiply out. Then we know we have this, not AB. I just want to see if it's a rule on its own. If it's a rule on its own, you see here it is. Do you understand? This is the absorption rule. Absorption, right? They are slowly coming back. So you can just cheat. Come on. Sharp. And then we said this is the absorption rule, right? Because it absorbs. This was 3, now it's 2. Okay, now let's start here. This we said is going to be distributive law. So how do we challenge this one? So we need to multiply out the brackets. So when you multiply out the brackets, just like in, was it grade 6? Okay, or grade 8. A and A, B and A and C, B and C, right? 4 times. So A multiplied by A is going to be A, or this one in the middle, AB, it's BA, but let's say AB so that it's easy to read. And then AC, the outside, you multiply by C, A, C, then you OR it with an A plus not AB. Okay, great stuff. So AA, I think, is the identity rule. Or idempotent. AA is an A, idempotent. AA, so we're just gonna put an A here. Is the idempotent law. Then we're gonna have A, B, or A, C, not AB. So the name of that law was idempotent. Idempotent law, okay. So now we are here. We know A and A can be a common factor, right? Then we're going to have 1 plus B. This is what I was rushing for. Remember that one we couldn't do anything? This is actually a perfect example. We couldn't do anything because it was a knot. That's why we had to leave it like that because of this knot. If it was 1 plus A, we're going to do something with it, right? So let's see. Let's factorize this. This becomes an A. A multiplied by what gives us an A? A 1. Or A multiplied by what gives us AB? A B, right? A and then AB. Okay, so now 1 plus B, what is 1 plus A? 1 or A. 1 or A is a 1. Annulment law. 1 or A is a 1. Annulment law. So here we're gonna have an A. This one they like asking it because this 1 plus B. Stuff. So we know we have A alone now. And then here, let's see what we can do here. We have AC, then we have A not AB. We know this A not AB. We know it's this absorption rule. So let's just try to prove it or work it out. Let's leave AC. Not AB. Okay, so now here we have A. We have A, or we have this A, right? Or AC. You see what it means? Common factor again here. So let's do that. We'll finish off this side just now. Okay. So now what do we have? So we are actually having A, it's out here, in brackets, A multiplied by what gives us A? A multiplied by 1 plus A multiplied by what gives us AC? C, right? Since we've done this thing so many times, 1 plus something, 1 plus 1 is a 1 annulment law, right? 1 plus C is a 1 annulment law. So it's a 1 annulment law, right? It's this. Here we're going to have A as it is. Sure. So now, coming this side, we have AC. So we had this, we took A, or we continued here. We just write it down. Stop being lazy. Plus not AB. Plus not AB. Then here, we took this AC here. So here we just left with A plus not B sharp. Then now we have this. So here we need to think, how are we going to do this one? You can simply cheat and summary say is equals to A plus B. right? I think I don't know how to prove this one, hey? Let's think, guys. You can help me. A plus not AB. We can't take out A. We can't take out this. Oh, it's that one where you need to work in reverse order. Let me show you how. You see, you have A. I think I have an example where I am working it out actually. Not A. Yeah, this is as difficult as it can get. So this A, remember A is the same as not AA is the same as this, right? Something like that. But let's see from our notes. So we're gonna do that. I know AA is an A and not A is a 0, right? So AA is an A and not A is a 0. Yeah, okay. Let's see what we can do with it. So our final answer here must be A plus B. For this, it must be A plus B. So if we say A, AA, then here we say not AB, then what is the use? Because we can't take out anything. So I think we need something that has a not, right? So let's see. A, not A, it's a 0. A plus, not A, it's a 1. So we need one of these two. But we can multiply that by 0, because if we multiply it by 0, that thing is going to escape. Or we can use A and 1. It's somewhere here. Let's see. Okay, yeah, you see it. So we know the first step, guys. Sorry, this thing. So you see, we know the first step. The first step we got right. AA. AA, we are fine here. Plus AB plus not AB. Yeah, do you guys see anything here? Please assist if you can. This I'm fine with it. Then where is this AB coming from? And I'm saying it's rule 10. I know it's rule 10. Oh, this rule. Yeah, sorry. So we need this rule. Okay. We need this rule, okay? So we're working backwards. So now that rule is saying, it's saying this whole A is A plus AB. There's one thing of doing it. Okay. A plus 1B. I'll show you now. And then this is the same. So this A we substituted with with A plus. I jumped to this one immediately. So we substituted this with the whole thing. Okay. Understandable. And where were we? Where were we? Control Z. So we still here A or not AB, right? Let's see if it matches our thing. A or not AB. Perfect. It matches our thing. So we're going to start with the top one first. So we're going to start with this absorption rule, right? A plus A B is equals to A. This one we can prove it. We're just going to take out the common factor, which is A. It will be 1 plus B. 1 plus B is a 1 anyway. It's the annulment. I dependent. What rule is that? 1 plus something. Then it will throw away this. We will only have the A. So now we need to work it backwards. It's this law, 1 plus something. It is this law, right? So we're going to be left with A. So now this is how we did it. We said A, we took it back to the absorption rule. We said A is the same as A, confirm here, A plus AB. A is the same as A plus AB, right? Sharp. But now, let me show you why. Let's go from this A plus AB. A plus AB. Let's prove that it's equals to A, right? We take A as a common factor. Then we have 1, or A as a common factor, 1 or B, right? Then we know 1 plus A is a 1. And the name of the law is 1 plus A, annulment law. Annulment law. So this is just working backwards, right? Working backwards. So now we know this A, they replaced it with A plus AB, right? Then we still have this here. Not AB. Okay. This is annulment law. We have an A here. Then we have this. Not A, B, right? Right. Okay. We almost there. So now we did this, and then I said this can also be this can also be AA. We're working backwards. A can also be AA. Where's the law? AA is an A, right? So this is AA. That's the only thing that I'm saying here. And then we have AB. Then we're going to OR it with not AB. Not AB. All right. Great stuff. So we are almost there now. We are almost there. So by looking at this, right, here I can I can take out common factors here. I can have A okay, I want us to work it like this first. Let's go to the thing. I want us to work it like this. Okay, so we are definitely here. AA, AB, not A, not A, not AB, right? Then we factorize in here. A. What did we do here? Factorizing. Let's see. Then we have A, B, not A. Sharp. I understand this. And then here, A multiplied by this AA. AB. Okay. Sharp. we factorize here. I want us to do it like this. Let's go that way. Yeah, so this was a lot of math. So, but we're supposed to have, how many should we have? We're supposed to have so many variables. We're supposed to have 1, 2, 3, 4. Is it the one? Yeah, okay, it's this one. Sorry. 1, 2, 3, 4. Let's just confirm that we have that. 1, 2, 1, 2, 3. Yes, this is our problem. Which one is lost here? AA. Let's check if we have AA. We have AA. Where is our AP? We have AP. So we have AP. We need A, not A. So where did it come from? It came from this one. Here. Okay. So this not AB. We multiplied it out. So let me show you this. Not A and B. Ne? So we have this AA, we have this AB, so we don't have this one. So it means that A and not A is equals to A. Rule 8. Yeah, here they were killing you guys here. Okay. Let's see. So it means this last one needs to be multiplied again. So if we go to our rules, A and not A, I'm getting a 0 for A and not A. You guys with me? A not A, it's a 0. So it doesn't exist. Oh, so A not A doesn't exist. Yes. Okay, and then we have this not AB. So we just put this. This is not part of this. They just put this for the 0 now. And then we have not AB. So now I understand. Now it makes sense. So before that, great. So now before that, we have this AA, then we have this A, we added another A, right? Then we took AB as it is, right? AB as it is. So here, for us to be able to group this 4 together, to group the 4 together, and this is what happened. They they added a 0 with what? They added a 0. If you add a 0 to this circuit, it means it's not changing the circuit, right? So now they did an A, not A. So A not A is a 0. Here it is. It's here. A not A. A and not A is a 0, right? Just for you to be able to simplify. Sure. So we have our AB, we have A not A, and then we have this. Not A, B. Okay, now let's leave this A as it is here. Now we are here. We're going to have 2 brackets for this, right? So here AA, this is x squared, remember? A, the same as A squared, right? Then we need AB. Remember, you multiply this and this, and then you multiply this, and then you multiply the outer one as well. So A multiplied by A is AA. So now we want AB. So if we put the B here, let me just see. If we put the B here, we're gonna have AA and then we're gonna have AB, right? And then we need to put a not A somewhere. Let's see. So let's see what is this. A multiplied by A, AB. So we have this, and then we have A, not A, and then we have not AB. So okay, it's correct, it's correct. It's correct. So okay, sorry for that. So this is correct. Let's just check how we did it there. A or not A, and then A or B. A or not A, and then A or B, right? So it's fine. So we managed to get it. So they took it to this distributive form first before they could come here. These people. Okay. Let's see. Then from there, I can see that what did they do? They took this one is a 1 and then they left this. Okay, and then they multiplied. That's how they got the A plus B. All right. So A or not A, we go to our loss. A or not A, A or not A, A or not A is equals to 1, right? Is equals to 1. And let's start with that one. So we have A, we have A plus B, then A or not A is equals to 1, right? So our final answer here, it's A, but we're still gonna simplify it more. A, AB, which is equals to I think it's fine like this. Yeah, okay. This is our final answer because the only thing that we can do now is this can be AA. Let's see. Yeah, we need to do it because this is another law. AA or AB. A multiplied by A is AA, right? A multiplied by B is AB. Then we know A and A should give us an A, I think. A and A is an A. It's idempotent law, right? So here we will have A plus AB. Yeah, so the answer here is going to be A, right? A plus AB. We can see that we have a common factor here, then we can have B plus 1, and then our answer will be A, right? So how do we do that? We take out A. A. Okay. Then we say A multiplied by 1. It's an A. Then A, what is missing here? It's a B. So this will give us A multiplied by 1, which is an A multiplied by B, which is a B. We know 1 plus something, it's just a 1, right? A plus 1 A plus 1 is a 1, annulment law. So this will be A with a 1. Annulment law. Yeah, no, this one was a long one. Okay, this is the final answer. And this, they can ask it because it's already in your notes. Eh? They can ask it. So go through this. You see, it's here. You are able to prove this. A and A. You take out A, then you say 1 plus B, right? Distributive law. Then this will give you a 1, right? It's that A and 1, I think it's idempotent. Idempotent, A and 1. Identity, okay. A and 1 is identity. A and 1, and then your answer is A. So practice this, and then this one is to prove this. So they might ask you to prove it, and you see to prove it really killed us because we had A plus AB. We had to put in the AA, right, and AB. Then we also had to add a 0, A and not A. We had to add, so we put in this, then we put in this. Then from there, we had to factorize. Then we got A plus B, right? But now there was also an A variable outside, which helped us to take out A as a common factor, then be left with 1 plus B. So this practice as well, try to understand this. Here's another one that I can say you must prove. This one is simple because you are distributive. You are multiplying out. AC is this outside, and then AB, and then BC, right? Distributive. AA, you know it's an A. AC stays AB, BC. Take out A as a common factor, you're left with 1 plus C. AB plus BC. 1 plus C is a 1. So you're left with A, AB, and BC. A, yeah, you had an A, right? Multiply by 1, it gives you A plus B, it gives you this. Then you know A and 1 is an A, right? Practice that one. And then from there, next time we will look at this De Morgan's theorem. De Morgan's theorem. So we still need to look at, today we took long on this thing. Let me just stop this. We took long because we're supposed to look at the Carnot maps again, right? So this Boolean algebra, make sure that you know this